right, this is the third video for these, 5.3 notes for trig. So we can find the sum of two angles even if the angles are not specifically given to us. So if we're given information about the two angles, we can use the information to draw the angles in standard position or use the Pythagorean identities to find them. So we're going to do the same problem twice using the two different methods. Some of you are visual, some of you like to just use your formulas. So the first one says, suppose that the sine of s is 3/5 and the cosine of t is negative 12 over 13. Both of them are in the second quadrant. They want us to find the cosine of s plus t. So s and t are both in the second quadrant. So first of all, I'm going to worry about, say, my s, my angle s. So remember, S and T are angles. They're both in the second quadrant. So this one's my angle S. Angle S is in the second quadrant, so there's angle S. And what do I know about this? I know that the sine of S is 3/5. So that means opposite over hypotenuse, we've got 3 over 5. So just really quick, while I'm looking at this triangle, I can use the Pythagorean theorem to find the fourth side. Now, some of you might recognize that this is a Pythagorean triple, so this is 3, 4, 5. Remember that that's going to be negative since it's the x value, and it's in the second quadrant. We're on the negative x-axis, so that's negative 4. So we've got that, and one of the things we're supposed to find is the cosine of s. Well, this was angle s, so I can actually look at that triangle and decide, okay, well, the cosine of s, that's adjacent over hypotenuse, so this is just going to be negative 4/5. So I just drew a picture to figure out what that value of cosine was. I knew the sine of s, but I didn't know the cosine of it. Now I have this whole other angle, angle t. It's also in the second quadrant, but it's not necessarily the same angle as cosine of s. So angle t, right there. And what I know about angle t is that the cosine of it is negative 12 over 13. So adjacent over hypotenuse, negative 12 over 13. So you might recognize this as another Pythagorean triple, 5, 12, 13. So I know that one's 5. If you didn't know that, just use Pythagorean theorem. You do 169 minus 144, that's 25. Square root of 25 is 5. So we've got that side now, and we needed to know the sine of t. We knew the cosine of it. Well, the sine is opposite over hypotenuse, so I know the sine of t is the opposite side over the hypotenuse, so 5 over 13. That's positive. Okay? Now, the whole goal, it said find cosine of s plus t. So in this case, since we want cosine of s plus t, I need to use my formula, my sum formula, that says, okay, that's going to be the cosine of s plus the cosine of t minus the sine of s times the sine of t. And I can fill in what I know. Cosine of s, I just figured that out. It's right here. Cosine of s is just negative 4/5. This is supposed to be times, not plus. Times the cosine of t. Well, the cosine of t, they gave us. That's negative 12/13. And we have minus the sine of s. The sine of s they gave us, that's 3/5. And the sine of t we just figured out, that's positive 5/13. When you multiply that, we've got negative 4 times 12 is 48. 5 times 13 is 65. Minus 3 times 5 is 15. Over 5 times 13 is 65. Same denominator, so we can keep the denominator and do the subtraction. 48 minus 15 is 33. So our answer is just 33 over 65. Your other option basically turns out the same. It's going to have this part of the problem as the same, but to find your cosine of s and sine of t, it would be a little bit different. So we could have, if you didn't want to draw these pictures, we could have used the Pythagorean identities to find cosine of s and sine of t. So given that the sine of s was 3/5, I could have used, all right, well, sine squared s plus cosine squared s equals 1. And since I knew sine squared s was 3/5, I could have said, all right, 3/5 squared plus, I don't know cosine of s, so cosine squared s equals 1. And just like we've done before, 3 squared is 9, 5 squared is 25, plus cosine squared s equals 1. Now I'm going to subtract that 9/25 off both sides. So I'm going to have cosine squared s equals, I'm anticipating subtracting a fraction, so I'm going to write 1 as 25/25 minus 9/25. So 25 minus 9, that's 16. So I have cosine squared s equals 16/25. Now I want the cosine, not cosine squared, so I'm going to square root both sides. Remember your plus or minus. And that gives me that the cosine of s is positive or negative, plus or minus, but we'll talk about that in a second. Plus or minus the square root of 16 is 4 over the square root of 25 is 5. Now that plus or minus right now, oh, you can't even see that. That plus or minus right now, I know that it's in the second quadrant. The problem told me that my angle S is in the second quadrant, and cosine is negative in the second quadrant, so I know instead of plus or minus, I can put that negative. And you'll see that's the same thing I got when I did the drawing. It's just some of you like it visually, some of you like to see the algebra behind it. I'm going to skip doing the same thing for t, but you could have done the same thing for t. You're still going to use sine squared t plus cosine squared t equals 1. This time you were given the cosine of t is negative 12/13, so you'd have said sine squared t plus negative 12/13 squared equals 1, and you would have carried on and eventually gotten that the sine of t is positive 5/13. So remember, sine is positive in the second quadrant. And again, with those two pieces of information, then you would have come up and done the same exact thing if you wanted the cosine of s plus t. We have one last thing to do. We have to verify that the following equation is an identity. So we have that task at hand. All right, to verify this, we always start with the more difficult side, which is right here. And I see that it's a difference, but it's a difference with secant, and we don't necessarily have a rule for that just yet that you've learned. So I know that secant is the reciprocal of cosine, so this left side is going to be equal to 1 over the cosine of that same angle, 3 pi over 2 minus x. Since that was secant, remember secant is 1 over cosine. So this looks really messy, but we just learned about our sum and difference formulas. And so the difference formula for cosine says the cosine of your first angle, so 3 pi over 2, times the cosine of your second angle, which is x. And since this is a minus my formula, I have a plus. The sine of 3 pi over 2 times the sine of x. Now that looks like a really big mess, but 3 pi over 2 is a quadrantal angle. 3 pi over 2 is the same as 270 degrees. You can see that right here. So I know the sine and cosine of it. So I'm going to leave that right there. So the cosine of 3 pi over 2 is 0. So we've got 1 over 0 times the cosine of x, plus the sine of 3 pi over 2 is negative 1. So I have negative 1 times the sine of x. So 0 times the cosine of x, that's just gone. 0 plus a negative 1, so that's negative sine of x. Now 1 over sine is cosecant. That negative hangs out there, so I have cosecant of x, negative cosecant of x, and that's exactly